So hello and welcome to this new video in which we'll be comparing two RAG pipelines, a naive RAG pipeline versus a pipeline that uses semantic chunking. We will be evaluating these RAG pipelines by using Ragas framework, Ragas assessment across 5 key metrics which are faithfulness, response relevancy, context precision, context recall, and answer correctness. So as always, we get our OpenAI app API key, we get the Langsmith API key which will be useful for visualizing the traces of our RAG pipelines, and next we can proceed with the synthetic dataset generation. So to make things easier for ourselves, we will be using the abstracted method that will be in charge of creating the knowledge graph, and what we achieve by using this method is to reduce the complexity of manually creating this graph ourselves. So first, we load the documents that we have in our directory, this PDF, by using directory loader, and with the loader class PyMU PDF loader, we split the document where we know that this loader class splits the documents under the hood. So from one PDF, we get 64 documents that are going to be the nodes of our graph. Next, we instantiate the generator LLM, which in this case is GPT 4.1, in the generator embeddings. The generator LLM, as we know, is in charge of creating the questions, the summaries, the headlines, and the themes that are going to enrich the nodes of our graph. And the embeddings are going to be useful for establishing the relationships between the nodes using asymmetric cosine similarity. So we instantiate our generator using testset generator, and we use generate with LangChain docs to generate our dataset. So here we run the cell, and we get the dataset, which has user input, which are our synthetic questions, the reference context that are like the actual chunks from our PDF that have been taken for context, and the reference, which are the desired or ideal answers that our model should generate. Next, let's go with the baseline RAG pipeline or the naive pipeline. As always, we start with the R of retrieval. We load our documents as before. We split them using a naive method, just with recursive character text splitter. We instantiate our embedding model using text embedding resmod. We instantiate our quadrant vector store. We add the documents to the vector store. We instantiate our retriever, and now we are ready for our first node, the retrieve node, that, as we know, it takes as input the state, extracts the question, and with the retriever gets the context, and updates the state with the context. Next, let's go with the A for augmented. We create our RAG prompt template with the question and the context. We instantiate our chat prompt template from this template, and next we go with the G for generation. We will be using for the generator GPT 4.1 nano, and we can create our second node for generate. That, as always, it takes the state and makes a series of transformations to the state. So it gets the context, the question, generates a response, and updates this response with updates the state with the response. So next, we can already create the graph, as we have already our nodes. So we create the state, and we instantiate the graph with our black canvas with state graph, and we add the sequence of nodes. We add retrieve and generate. And as we know, add sequence already adds the edge between retrieve and generate. And all that is left is to add the edge between the start and retrieve. We compile our graph, and we already have our first RAG pipeline, our naive graph. So now we can start with the improved RAG pipeline that uses semantic chunking. Specifically, we are going to implement a semantic chunking strategy that groups semantically similar sentences together and uses a threshold to determine similarity. So we will be leveraging LangChain experimental with semantic chunker that already has this functionality that already allow us to make use of this functionality. So we instantiate the semantic chunker using as model text embedding resmod, which measures the semantic shifts between sentences, and we use the same model as the retriever for alignment. We will be using as breakpoint threshold type percentile, and the amount is going to be 90. So lower, it means more cuts, and higher, it means fewer cuts. We get here 171, which is lower than the naive approach. So we are hoping to have like fewer chunks, but bigger chunks, so more context. We use this semantic splitter to split the documents, and then we can proceed with instantiating our embeddings, creating the vector store, the quadrant vector store, adding the documents to this vector store, and instantiating our semantic retriever. Next, we create the next node, the first node for this graph, which, as always, takes the state, takes as input the state, then takes the question from the state to get or retrieve the documents, and updates the context with these documents, which is the output of this node. Next, we create the semantic state, and now we can create the graph. We use our blank canvas state graph. We add the sequence retrieve semantic generate with the edge between the two. We add another edge between start and retrieve semantic, and we compile our new graph, which is the semantic graph. Now we are ready for evaluation with Ragas. So first thing first, again, we instantiate our evaluator LLM, which is going to be GPT 4.1 mini, and the metrics for evaluation are going to be faithfulness, response relevancy, context precision, context recall, and answer correctness. So what we have to do now is to run all the synthetic questions through the baseline RAG pipeline. So we run the questions, we get the response from our model, we append it to our evaluation dataset, we get the context that the model has used for generating these responses, we append it to our evaluation dataset, so to our testset dataset, sorry, and next we create our evaluation dataset that follows the evaluation scheme, which is different from the testset schema, and that is needed to run the evaluation. So now with our evaluation dataset and with the metrics, with the LLM, we run our evaluation and we get our baseline results. Next, we do the same process with the semantic RAG pipeline. So we copy our test dataset to get the semantic dataset, and we run the synthetic questions through the semantic RAG pipeline. We get the responses from the LLM, and we get the context that the LLM has used to generate that responses, and we append those in the semantic dataset. As always, we need an evaluation schema, so we create our semantic evaluation dataset, and now we are ready to evaluate this semantic pipeline. So as before, we use this dataset, the metrics, the LLM, and we run the evaluation. After running the evaluation, we get the semantic result, and now we are ready for analysis. So I made this code here just to get this table here, the metric comparisons, and as we can see, we have the semantic results and the baseline results, and the semantic RAG pipeline has achieved better results in almost every metric when compared with the baseline. What does this mean? It means that semantic chunking groups the sentences by meaning, and that provides a retrieval that is more on topic or grounded, hence boosting faithfulness and answer relevancy as well as the other metrics. And what we can also see is that we have experienced a small answer correctness dip. So how could we improve this performance? Well, we can fine-tune the chunk size or use re-ranking, for example, by using Cohere. So thank you so much. I hope you have enjoyed this notebook, this video, and see you next time. Bye bye.